red LEDs and the shift register. So what this is doing is using a shift register chip or an integrated circuit as the controller of the 8 red LEDs. And the controller has a data input, which is pin number 2, a clock input, which is pin number 3, and a latch, which is pin number 4. What we're doing is essentially giving the chip data to control the LEDs. So how this works is we basically clock in the data and then we lock it in or latch it in. So we use pin number 3 to clock it, we use pin number 4 to latch it in, and then we pulse the latch and the 8 bits are transferred to the shift register pins, which then control the LEDs on and off. So right here we have the beginning, say used for the single LED manipulation. So we have either a constant on high or a constant on off, which equals a low. So the input's high for on and low for off. We then have our void setup. The pin mode data is an output, and then we have a pin mode and a clock is our output, and then finally we have a pin mode latch as our third output. So with our outputs defined, this is our another void loop, so we are telling it to give it a delay of time for 100 milliseconds between each LED update. This is the code for each update. This is the variable that we're changing, which is I, and then we're delaying the time again for 100 milliseconds. So this is the sequence update for the shift register. So what this is doing is basically sending the data from up here, latching it first on low so it's off. Then we're shifting the data, clocking it, and sending out the 8 bits to the shift register to the actual chip. And then we're locking it in with the latch. We then, or the board then uses the update LED long code or program to then delatch or repeat the process of what that just did, so that it changes the way it just turned on and off all of the LEDs. This is a condition, I believe. So if the 8 bits are set, then our data pin is high. If the 8 pins are unset, then the data pin is low. So essentially, if the 8 pins are set, the LEDs are on. If it's low, the LEDs are off. We then clock it on high, so we're sending data out to the chip register, or the shift register, I mean. And then we're clocking it on low after a delay of 1 millisecond. And then this last line is basically taking what we just did and displaying it on, or with, using the LEDs. And that's pretty much what the code is doing to manipulate the shift register and how it's controlling the 8 LEDs.